So let's talk a bit more about protocols. I've listed here a number of common protocols that it would be advisable to memorize and learn. You'll be using all of these in some fashion throughout your time in IT, especially networking. So make sure you understand the basics of each of these, and we'll go through some of the details on these throughout this video. So the first one I have here is DNS. So we have domain name system. So this is a real old protocol, dates back to the very beginnings of things, and it works off of TCP and UDP on port 53. The UDP is what we normally use when you request google.com or cisco.com. It'll resolve that name to an IP address and then return that IP address to your system to let it know what IP it needs to put into that header when it encapsulates it on the network layer. That's done over UDP 53. The TCP side is used for when it needs to synchronize and replicate a database from one server, one DNS server to another. It'll use TCP to ensure that that data is correct and hasn't been mutated during its transit. DNS otherwise is done with UDP for clients. If it works, great. If not, the client will just request again. No big deal. So we have HTTP is next. That's a hypertext transfer protocol. That's used for displaying websites. So when you go to any sort of website, you are using HTTP, which is also a relatively old protocol. And that works off of TCP port 80. It can also be other ports, depending on what you're connecting to, especially internal servers. Quite often 80 is used by something, and then some other application that needs to run a web service will need to be started up, and so that you might see it on port 8080 or 8000 or something like that. It's common, it starts with an 8 at least, but by default for the internet it runs on port 80. We have HTTPS, so Hypertext Transfer Protocol over SSL, or called Hypertext Transfer Protocol Secure, but it's over SSL, and that runs off of TCP port 443. Very common port you'll see all the time. And later on at the end of our videos we'll talk a little bit about remote access for people, and one of those you can set up is SSL remote access. That actually runs over port 443. We also have SMTP, so that's a Simple Mail Transfer Protocol that runs over TCP port 25. SMTP is used by mail servers to send mail between servers, and it's also used by a client on your client PC to send the mail to the server in the first place. So Simple Mail Transfer Protocol is meant to send the mail essentially, and that uses TCP 25 so that the email does not get lost in transit, and it always ensures that it's acknowledged and it actually gets to where it's supposed to go. Another very old, and all these are very old protocols. POP is a very old protocol, post office protocol that runs off of TCP. You'll see this a lot. A lot of things run off of TCP port 110. And as I go through these, you're also going to want to know the port numbers. I have seen questions like that come up. So it uses TCP port 110, and that's used by a client requesting to check for new mail from a post box on the mail server. So SMTP to send, POP to retrieve. There are other protocols out there like IMAP, and we know you have push and exchange sync and things like that. But for basic mail, it's either POP, SMTP, or IMAP. But IMAP we don't really go into detail. We also have Telnet, which we just talked about in the last video. That's on TCP 23, very common, used for shell-based applications, console console-based applications with no graphical interface. It's also used for management of switches and routers and network devices. Unfortunately, though, it doesn't offer any sort of encryption or security besides plaintext passwords, so it's not really preferred to be used. Alternatively, there's SSH, Secure Shell, that runs off of TCP 22, which is the preferred method. And as we go through our configuration videos, I'll show how to set up SSH access on a Cisco device, so you can configure it and manage it, and people can't see what command you're sending, and they can't see what you'd use to log in. We have FTP, File Transfer Protocol, which runs off of TCP, ports 20 and 21, although primarily 21. 20 is kind of an old method. The new method, and that's called active FTP, when it runs off of 20 and 21. So 21 is the signaling port where it says let's create a session and we're going to transfer some files, and then 20 was used for the data, but it was considered insecure, so they changed it, and now we have what's called passive FTP, where it'll use port 21 to bring up the session, but then it'll choose a random port number to actually send the data over. And I'll put that there, plus random. And that's used for pretty much most downloads. You can also download files. HTTP was updated many years ago to allow HTTP downloads for files. Previously on the internet, a long time ago, you could only view web pages on HTTP, and you could only download files through FTP. Since then, they updated HTTP to allow file transfer, so when you download files, it can go across either of these protocols. Usually FTP is faster because it's designed to transfer files, and it has a smaller overhead for transferring large files. But HTTP is often easier and simpler to transfer with, especially in modern web browsers. We have DHCP next, a dynamic host configuration protocol that uses UDP, ports 67 and 68. And DHCP is used for obtaining IP addresses and other addressing information for a client. So each computer that you have out there, each client doesn't have, or phone or any sort of end user device, doesn't have to be pre-configured with a static address and static DNS information and static default gateway information and Win server information and all sorts of stuff. DNS domain, that can all be handed to it by DHCP. It's a very handy, very common protocol to use. The way it works, though, is you can only really have one at a time running, so there's tricks you can do to make it work with multiple servers for failover capabilities, but also a very old protocol. Very, 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 very common. SMB, Server Message Block, also now known as CIFS, Common Internet File System, which is now a standard. SMB started as a Microsoft protocol and has now been standardized as CIFS. That runs off of TCP port 445 or UDP, ports 137 and 138. And there's a lot of ports for this. TCP 137 and 139. So it can be on any of those. But it's used for file transfers in Windows systems, an alternative to FTP essentially. When you drag and drop files using the Windows Explorer between systems, maybe between your server at work and your computer, your workstation, it'll use SMB to do that. Unfortunately, SMB/CIFS is a very chatty protocol. Has a lot of overhead. It's slow. I'll be honest, it's slow. If you talk to any protocol analysis people, they don't usually like SMB. because it's a very chatty, very bloated protocol. It's usually faster to transfer things using NFS, which is another protocol used for Linux systems, or FTP or something else. But it's very pervasive because of Windows. There's TFTP, the Trivial File Transfer Protocol, and instead of running on TCP like its big brother, it runs off of UDP, port 69. So TFTP does not provide any sort of acknowledgement of the transfer working correctly, but the software application and service on the server side usually have some sort of system put in place to ensure that the file is actually correct, and it will do some sort of checksum acknowledgement to make sure that the file that's transferred is the file that it expected and it didn't get corrupted in transit. So even though it uses UDP and it's supposed to be faster, it really does do a similar thing, similar process as FTP to ensure that the data is transferred correctly. And lastly on our list here we have SMTP, Simple Network Management Protocol, and that uses UDP, ports 161 and 162. And we'll talk more about SMTP later on in the video series. 161 is used for the retrieval or polling of values from systems to determine, how much load is on the CPU, how much memory is being used, what's the hard drives look like, any sort of value you can possibly think of, not just that, but I mean anything. And then 162 is used for traps, meaning the actual device itself then can also send alerts, essentially traps, back to a server to say, hey, this thing changed or this thing broke. That uses port 162. We'll talk more about that later. And then there's other protocols, as I mentioned, like NFS and such, Network File System and that, which are also commonly used, but these are just some of the basics that you'll need to know. I would definitely spend the time to know these protocols, know the port numbers. They're very handy, not just for the exams, but also in life, in IT with networking. You'll see these come up constantly. I mean, most of your traffic will be some sort of collection of these protocols. So, as I mentioned, DNS is, we'll switch colors here. DNS is a very old protocol, but it's still in use. It's been upgraded in the last few years a little bit for DNS security because of some flaws that have been discovered. But it's still heavily used by every single network out there. Without it, everyone would have to know the IP address, or either IPv4 or IPv6 address of every single system that you want to try to access, and humans just can't do that. It's just too much. So instead of going to google.com, you'd have to go to 162.237.something, whatever it might be. So the basic idea of DNS is that it resolves that name, google.com or cisco.com, into that IP address so that you don't have to know it. The DNS resolution is done before data connection to the server, and before service is initiated. It has to find out what IP address to use to put it into that header for it to encapsulate and then send it onto the wire. You have to use it for the World Wide Web. If you want to access any sort of website, you're going to be using DNS. And we'll show some of that as we diagnose and do some things in the future. If you do a Wireshark capture of yourself going to a website, you'll see those DNS queries pop up. You can test DNS by doing Nslookup. So we can do that now, actually. You can do Nslookup, google.com, and there you go. It'll show you all the different addresses that you can use to access google.com. And actually that top one there, 2607, that's a IPv6 address, as well as a bunch of IPv4 addresses. Also with Nslookup, this uses your locally defined DNS server, which I think here that I use is it goes to my router, but the router actually uses OpenDNS. But you can also define the DNS server you want to poll. So I can poll Google themselves. Google runs their own DNS servers on the 8.8 range, and you can actually poll them to find out from that server what its database says. And you can see there's a whole bunch of different IPs it allows you to access as well. They have a very large range. So that's what you can do to use. You can use Nslookup on any operating system, basically. You have a number of different record types. There's A records or quadruple A records for IPv6, and that's just IP. Basically, that's what we're seeing here. You can have NS name server records. You can have CNAMEs, which is a canonical name, which is basically like an alias, which gets more involved when you're doing like website design and website hosting. A lot of CNAME use in there. Sometimes for like domains and stuff internally as well for businesses, they'll use CNAMEs. And then you have MX records as well, mail exchange records, which is used for email. An email server will do a DNS query and look for the MX records to find out what servers it can send its email to get to you. And that's also how spammers find you. Client and servers will check their host files first on Windows. There's a host file as well as Linux and all the others. And it will go check that host file before it goes and queries DNS. So you can override your DNS by editing that host file and adding your own definitions in there, which is very useful when you're doing diagnostics of different kinds. You can also do ipconfig in Windows, and you can flush your DNS, which we have a local DNS cache on a client system. So whenever we do a query like nslookup google.com, those entries are now cached for a certain period of time on my system, so that I don't query every single time, because that'd be very wasteful. If every single time I try to go to google.com, I have to go query and find out, hey, where do I go? It'll query that, save it locally in a cache. Well, sometimes things update and something changed. Maybe we're not talking about Google here, but maybe if you're changing something internally in your business, the DNS might be wrong. It'll point to a different server because you changed servers or upgraded or something. You might have to flush your DNS, and it'll clear out your cache. Another one you can do is display DNS. Well, actually, I'll do that here, which will display that cache, which you can then flush. A lot of stuff going on here. There's a hierarchy system in DNS. There's root servers that control the upper level of DNS. They're also called root hint servers. You have top-level domain servers such as .com, .org, .net. Those are servers themselves. And then you have the second-level domain servers of youtube.com, google.com, cisco.com. Those are below those. And when you do a query, you'll actually hit each of those servers to try and find your way. You might hit the root hint servers first, and then they'll tell you what top-level domain to go talk to. You go talk to the top-level domain, and then it'll refer you to a second-level domain server, and then that second-level domain server will say, oh yeah, here's your records, this is what you're actually looking for. We also have HTTP. It's a very old protocol, as I mentioned. It runs the World Wide Web. Has a bunch of different message types you can send it. Get, post, and put are the most common. When you get something with HTTP, you're retrieving it, like you're loading a website. Posting or putting, you're sending something to it, like if you're filling in a form or something like that, you'll be using one of those commands. It'll transmit HTML, hypertext markup language, which then gets interpreted by your web browser and will show you the website. Actually, we'll do that. We'll go to Google. There we go. View source. And then it'll send you this over HTTP. It'll send you all this HTML. Your web browser will then interpret this and then produce the web page for you. SMTP and POP I mentioned, very old protocols as well. Used for sending and receiving mail. There's a bunch of different commands as well for that, like HELO, hello, creates the connection to the mail server. There's a newer version of that actually, that's EHLL. It's like the enhanced version. You can actually write email. If you're in a Linux system, it's actually pretty easy. You can open up SendMail and you can craft your own email using these commands. It's quite interesting. That's about it for SMTP and POP. We don't have to get too much into that right now. I mentioned Telnet allows for command line interface, CLI access, for management of devices or for non-graphical interface services, like if it's running off a Linux box or something like that. A lot of those are command line based, but it does not provide any sort of encryption and just plain text passwords. So it's not really recommended, even for internal networks. You should stay away from it. Stick with SSH, spend the extra 5 minutes and set it up right. We have FTP. Again, very old protocol. A lot of these are really old. They're from like the 80s and the 90s at most, sometimes earlier. Designed for sending and receiving files. I mentioned it's very efficient for that. There's the active and the passive modes. There's the secure version actually called SFTP or FTPS, depending on what version you want to use. Because FTP by itself, even with this random method, where it'll do 21 with a random port number, it's still not encrypted. There's, your password is still sent in plain text, and the data is still sent unencrypted. With FTPS or SFTP, it'll run it over SSH or SSL, depending, and that'll be encrypted then with those services, which is the preferred method nowadays. But a lot of places still don't support it, but that's available for you. I mentioned DHCP. DHCP is actually newer. The older protocol was called BootP, which was a simpler version of DHCP. It didn't provide as much, but a lot of services and servers, you'll see them referred to BootP as well. Usually you don't need it unless you have a very old device. Everything should support DHCP by now. DHCP, we'll probably see some packets of that going through the videos here. It works off of several different messages. There's a discover, where a device will broadcast, when it boots up, a device will broadcast out a discover packet and say, hey, who's my DHCP server? I need to talk to you. The DHCP server will then say, oh yeah, here, sure, I'll talk to you. Request something, request an IP for me. Here's an offer. I'll give you this. And then the client will send back a request and say, yeah, sure, that sounds good. I'll take that IP address. And then the server will then acknowledge that and say, okay, I acknowledge it. I put you in my database. We have SMB and CIFS, as I mentioned. You can actually, it's a Windows protocol essentially, but since it's been standardized with CIFS, you can run it in Linux. There's a service called Samba, which is very well known in the Linux circles, and actually CIFS is now native, I believe. So you don't necessarily have to run Samba. That was more for the SMB side of things, but you can do that. Usually on Linux, though, you'll want to lean more towards the NFS network file system, which is a very efficient, lightweight protocol. It's quite nice, actually. TFTP I mentioned, used for router and switch maintenance, mostly transferring files and configurations and things like that. And on our my Windows system here, I'm going to use that TFTP 32/64 application to turn my computer into a TFTP server. And SNMP, as I mentioned, is going to send and receive values of some kind. We'll get into that at the bottom of our video list here. Towards the end, we'll talk a bit more about SNMP and how we can send and set and retrieve values for devices, and pretty much every device and every operating system supports SNMP in some fashion. There's different flavors of SNMP. There's versions 1, 2C, and 3, and there's pros and cons to each of those. And then you can either get or set values for those devices. So, and then there's different systems out there that you can use to retrieve all that data and collect it in one place. There's a lot of different things out there like MRTG and Xenos and Nagios and such like that. cacti, graphs, and all sorts of things, where you can collect all that data from all your systems and get nice pretty charts and get alerts and things like that to make sure all your systems are running smoothly. It's highly recommended. I'm a big fan of SMTP. So from here we're going to get more details about the transport layer. We'll start seeing some more of the netstat, and we'll talk about how ports are brought up and how applications connect to ports and how they interact with each other. So look forward to the next video.